All right, let's do problem number 6 together. If an object starts accelerating from rest at a rate of 40 meters per second squared, how far does it travel the first second? All right. Is this thing in free fall? It doesn't say, does it? So now we don't know what the object is. So this will be what we call just a straight up kinematic thing. But let's start writing what we know and what we know. I don't know what the object is. Let's assume it's like a ball. And let's assume it's moving this way. Now it says it's starting from rest. So if we're going to do the x-axis, that means that going to the right is positive and going to the left is negative. Okay? So when it says from rest, that means that the initial velocity is what? 0. All right. What is 40 meters per second squared? What is that unit, meters per second squared? What does that normally represent? Acceleration. So we're going to say that our acceleration, and it's a constant rate, right, is 40 meters per second squared. Okay. Then it says how far does it travel in the first second? So what is time then? 1 second. Let's assume that this position here, x naught, equals 0 meters. And after 1 second, this is after t equals 1 second, this is our final position. That's what it's asking us to find, right? By the way, the acceleration is going to the right because it's a positive 40. Right, this is a positive 40. Okay. So now, what I need is I have x, x naught, a, t, and v naught. Take a second and look in your notes for an equation that has those variables, if there's one that has them all. Take a look-see. And raise your hand when you find one that you think works. Is your hand up? Or no, are you just holding your hand like that? You think you have one?
Would it be the x equals the initial, or x naught plus initial velocity times time plus 1/2 acceleration times time squared?
Yep, that's the one. So if I say x equals x naught, right, plus the initial velocity times the time plus 1/2 times the acceleration times the time squared. Because I have x, I don't know what x is. That's what I got to find. But I know what x naught is. I know what the initial velocity is. I have the time, and I have acceleration. So I have everything I need. It's just I got to do a little math. So I've got x equals 0 meters plus the velocity. The initial velocity is 0 meters per second times 1 second it doesn't matter. Plus 1/2 times 9.8 meters per second squared times the time, which is 1 second squared. So now when you what's 1 squared? Just 1, but when you square this becomes 1 squared and second squared, right? So that means that my seconds, whoops, I didn't mean to do that. That means that my second squared over here cancels with my second squared here. 1 squared is 1, 1 times 9.8 is 9.8. By the way, this is 0, 0 times anything is 0. So on the next line, I literally get x is equal to 1/2 times 9.8, which should be, oh, wait a second. I made a mistake. I've been doing a lot of free fall equations. What's the mistake I made? It should be 40 instead of 9.8. Oh, man. Well, in my defense, I've done like 10 problems today with 9.8. So it should be 40. My fault. So let's plug in 40 there so we can see it. So this should be 40 meters per second. Well, what's 1/2 of 40? 20. And it's just meters. So the last part is the common sense check. This thing is going at 40 meters per second squared. So after the first second, when we get all the way over here, this value over here is 20 meters. After the first second, it's gone 20 meters. Which, if you think about it, should be like kind of an average, right? You're going 0 meters per second. After the first second, you're going 40 meters per second squared. But half of that, you were sitting still, sort of, like what's 0 plus 40 divided by 2? That's actually another equation you could use, but yeah, it's going to be 20 meters. Okay. Any questions on that one? It's a good thing I turned my camera off because I keep yawning.